Welcome, everyone, to this episode of Manufacturing Talk Radio. I'm Tim Grady. I'm here with host Lou Weiss, who's also the founder of Manufacturing Talk Radio. And we have back on Artem Kroupenev from Augury. We were talking about artificial intelligence in manufacturing in our first episode with him, and we talked kind of high level. I think today we'd like to get into some of the real applications of AI in manufacturing. Artem, welcome back to the show.
Great. Really, really nice to be back here. Thanks for inviting me back.
I always like to have more.
Nice to have you.
Thanks.
I always like to have more detail. I was going over some notes, Artem, and something caught my eye called AI Copilot in manufacturing. An interesting phrase. Can you explain it a bit?
Sure. So in the previous episode, we talked about the implications of AI. What does it mean? There's a lot of hype around it. So I just want to make sure that, to put kind of a finer point on that, we talked about whether we should fear it. What does it mean for the workforce? Is HAL 9000 coming, right? And I said HAL 4000, mistaken. It's HAL 9000. Is that the future? And the answer is no. AI is a capability. It's an infrastructure that is ultimately going to make us smarter, better, more productive at what we do, at the things that we do. And for the manufacturing industry, ultimately, they will bring a lot of resilience, a lot of innovation, creativity, and so forth. So that's kind of that piece. The point I wanted to mention about co-pilots and AI-driven co-pilots, the idea is very simple. When you think about piloting an airplane, there's a whole bunch of systems today that are actually, only some of them or partially are AI-driven. Most of them are software and rule-based that enable today the planes to take off, to land themselves, to cruise, and to fly, and to take care of hundreds, if not thousands, of different actions that the pilot might need to otherwise do. And in some cases, do that, make some decisions whether to do this or that autonomously, right?
Mm-hmm.
And that has enabled us to really make aviation a hell of a lot more safer, more efficient, and a lot more ubiquitous as the introduction of these autonomous systems, and they keep improving. So a pilot today, in a commercial aviation pilot, is not able to really do their job effectively without that co-pilot capability, right? They can take the reins when needed in case of emergencies, but they can't really do their job day to day, and definitely not at the scale where we are in terms of commercial aviation. That same concept is coming to every industry and to every profession. So every type of knowledge work or every type of functional work where you need to make decisions, where you have a lot of tasks that need to be completed, where you rely on a lot of information to make those decisions, AI in its various forms is going to enable us to really do those jobs a lot better. And that concept can be called co-pilots or AI-driven co-pilots. I think Microsoft is really leaning into that branding with its own tools and applications. But really, it's a form of, let's say, hybrid intelligence, right? That enables us to do our jobs better. And there are many examples of that. One of the examples is, of course, when we talk about machine health and what Augury is doing, machine health, process health, we are building a form of functionality that enables co-piloting functions or whole roles around reliability and maintenance, as well as process engineering and operations. So now you have a smart AI-enabled co-pilot that can make the job of a reliability engineer a lot easier, a lot simpler, and take care of a lot of the different tasks and capabilities, and even some decisions that they're making today. And the future of that, of course, is that capability is going to improve, get a lot better, and make those functions a lot more effective.
I was just reading where in the medical field they applied AI to a cancer strategy for the most common form of liver cancer, and the AI came up with a possible approach to treating it in 30 days, something that normally takes 12 to 18 months. Clearly, AI will help us in the medical profession.
Yeah, I mean, there are various applications, but the theme is very similar to the way I described it. And the way to measure AI capabilities is to, at first, for us, because we don't really have a better concept of it today, but it is a useful way of doing it, is to measure it against human capacity, right? Human accuracy, human capability, human productivity and efficiency. And so there's kind of you can think about it almost as a scale. Is AI close or as good as a human at performing a certain task? And then when you get beyond human capacity, is AI more accurate than an individual human or better than an individual human? And is it as good as, let's say, 10 people, 100 people, or 1,000 people, right, at performing that specific task? So if you were to, in that medical example, if you were to take an expert, a medical professional that is able to make those types of diagnoses based on imagery or other data, then if you were to ask 100 professionals to make the same kind of judgment and kind of do the average and figure out do they get to the right decision, is AI as good as that, or 1,000, or even more, right? And so in some areas, we're rapidly moving certain areas, certain functions, and definitely within certain tasks, use cases, we're rapidly moving towards the ability of AI go well beyond human capacity. And if we think about the area of, let's say, machine health and predictive maintenance and process health, that is already the case for the last few years. With Augury, we have moved beyond human capacity in terms of accuracy and definitely in terms of scale. So, Augury's systems can monitor hundreds of thousands and millions of machines at once. So essentially, if you're a manufacturer, you would need a few hundred people to do that job semi-effectively, whereas you get that within a moment's notice. It's instantaneous. So that level of scale is just impossible to do through traditional methods. So that's how we can also measure the effectiveness of AI, the effectiveness of these co-pilots, if you will, in helping us do our jobs.
So this sort of takes care of the skill gap issue, does it not?
I don't think that's partially right. So that might be a part of the answer is that we are lacking skills at scale, right? So if we were to think about solving a specific problem by taking a bunch of people, training them and having them do that job, right, that takes care of that problem because it enables scale for certain functions, right, for certain use cases. But it does not take care of the general skill development for people, right? We are learning machines, we're learning creatures, right? And so we will and are developing new skills on how to take advantage of this technology, in a sense. So if you think about skills as something that is set in time, right, as a constant, then yes, eventually we will develop systems and platforms to make sure those skills capabilities are more and more scalable with the use of AI. But as we work with AI technologies, also our skills develop in making better use of them, right? So I think the more important skill for us to develop as individuals and also as organizations, as companies, especially within the manufacturing space, is to make use of these technologies and learn from them, and then make those technologies better, and then in turn make our own processes and capabilities better. So it becomes a continuous learning loop. And that approach to learning, that approach to skill development is what we really need to emphasize today.
So what is everybody afraid of? losing their jobs. It's like the blacksmith who, when the car came along, he was afraid, oh my God, I'm not going to be able to make horseshoes anymore. That conversion was probably a lot more difficult than what you're talking about.
Yeah, I think so. I think there's a couple of things. One is 99% of the world's population don't really understand this technology. Only 1% does. And that leads us to, get overexcited, and also to, leads to anxiety. And also, for companies that don't have a good understanding within their ranks, it leads to both an overestimation and an underestimation of the capabilities. That's kind of a double-edged sword. And
Right.
so I think that's one part. The other part is that this is one of the first times in history, I think, for manufacturing or industry in general, where we need both more people and more automation at the same time. Right?
Right.
It's just going to be impossible. So it's really the convergence between the two that's going to be both the challenge and also the exciting part. Yes, some parts of what we're doing today will be redundant in a sense, right? Or will be massively scaled with this type of technology. But we will rapidly develop new ways of solving problems and new functions and new roles. And that's already happening, right? And I think the mindset needs to change rapidly as well. That mindset of zero sum, or kind of set monolithic learning, right? That what happened before is what I will keep doing, or we will need to keep doing. But we need to change that into, we need to use these technologies, use these capabilities, develop our use case, says adopt them, and rapidly then find a new path, or our own path, in terms of how we will become better in terms of our own roles and functions, and maybe develop new roles and functions. The other piece is there's also a rapid generational gap, right? Technology is developing exponentially. And so there are people who understand how things were done before, or how they're done traditionally. And there are people who don't, but they understand technology, right? Or are used to using it. And so that level of reverse training or integration of how we train each other on understanding and coming with new cases is becoming incredibly important. So I think today, long gone are the days of like apprenticeship, or somebody coming into the job and learning all the ropes from scratch. When you come into a job with your tech savviness, if you will, or a better understanding of these AI technologies, you have to create an environment where both the people who exist in that role for 20, 30 years and the new people that come in are learning from each other synergetically and respecting each other's knowledge in a way that they can create something new. I think that is that approach is what's going to drive a lot of not just resilience in manufacturing, but also a lot of innovation going forward. So that's what excites me about it.
This is not too dissimilar, the time frame where in manufacturing right now in the United States, there's 3 million manufacturing jobs that are open, and we don't have people to fill them, or we don't have people who want to fill them. Well, the same situation happened in Japan after the Second World War. They lost a whole generation of men who worked in manufacturing. So they came up with the original, I guess, the original AI, and that's the robot. So they created the robot, and we're creating the broader version of that AI. So we're 70 years, 80 years later, we're in the same place.
I think we're in a similar place in terms of the technological evolution, or the nature of how technology evolves. I think there are a few key differences. One of the key differences is that the adoption and the rise of these technologies is exponential, where back then they were still nascent and quite linear in the nature. And that's fueled by a number of different aspects, but definitely the way we communicate today has changed dramatically. And so the consumer world and the manufacturing or the industrial enterprise world, they coexist at the same time and reinforce the adoption and also the rise of these technologies across the various use cases. So that has, so the pace has dramatically changed from them, from that time. The other piece, I think that people still don't have a very good, or a lot of people don't have a good understanding of, is that AI, when we're talking about artificial intelligence or augmented intelligence, that's not one thing. And you can kind of divide that into two broad categories. One is, you can think about it as intelligence that can understand and enhance the capabilities of things, right? So AI that understands things. The other type of AI is AI that understands conversations and people. And there has been huge advancement, in the last few months in terms of, the latest large language models that have, been open to the public in terms of the conversational AI understanding people. We tend to conflate between these two. But what you were referring to in terms of software that was used to run robotics and automation, 50 years ago, the evolution of that, yes, has gone through various phases, but today we're seeing AI, like AI around predictive maintenance or machine health and others, that can help make sense of and understand things and make them operate better at a large scale. When we talk about AI that can help us understand language and people, that is the part that was missing until very recently. And that changes the game a little bit. And that is because, we are now, as an organization, let's say as a company, we don't just function through our ERP system, manufacturing floor automation systems, through our databases, through our financial transactions. We function through a whole of a lot of, series of conversations between people within the organization, the documents that are shared, the presentations, the conversations with the customers, what happens in the boardrooms, the legal agreements, and so forth, the Slack messages, right, or the Microsoft Teams and the emails. That is really the heart and soul of the enterprise and almost any organization that until today hasn't been really, I would say, enhanced dramatically by AI. But this AI that can understand conversations can actually help us do that. So today we have AI can effectively run our production processes or help enhance our maintenance decision making and so forth, but also help us understand what is actually happening within our market, within our company, within the people that do that. And combining the two is going to be the next frontier that is dramatically different than any other kind of evolution or revolution that we've had before. So that is kind of the big differences, if you will.
So we are going through, I guess, the third industrial revolution.
I would say we're beyond the fourth, if that's if you keep count.
Okay.
So Artem, is machine health AI at a stage where it can say, okay, that machine over there has a part that will fail in 173 hours. I'm going to order it. I'm going to get it delivered by UPS or Amazon. When it arrives, there'll be a note attached to it that says it's going to go to this machine. Is it at that level yet?
Yes, and that's very exciting because it actually is, or very close to that level. The detection part, we can break it down into a few pieces, but essentially, are you able to detect machine failure? Can you accurately say what exactly it is ahead of time? Can you tell me exactly how to fix it? We do that today with over 99.9% accuracy. And just to give you a sense, when you ask really good machine experts, whether they're motivation analysts or reliability engineers, how well do they perform on these types of tasks? They're around 80%. Okay. So this is definitely beyond human capacity, but but it is a hybrid intelligence system in the sense that we have AI and we also have experts working to help customers make decisions at the same time. Then we're also working, we have partnered last year, I believe, with one of the larger logistical services providers and inventory management providers, where that's one of the use cases. We're actually working with a couple of customers on saying, well, you have a recommendation from Augury that says, this is the machine, this is the part, essentially the issue that you have, and here's how you will need to fix it. And then it alerts their systems to automatically order the spare parts that you need. So you've you've described a use case that we're in the process of deploying. But we are with a lot of our customers are already moving towards that autonomous maintenance, meaning that there's an Augury alert, you need to go and fix it, because the level of trust and reliance of the system is so high. We actually also ensure our accuracy. So if a machine fails on our watch, if you will, we have a program to repair and replace that machine, that component, which is the first industrial AI that's been actually insured, right? That just is the testament to its accuracy. So you can think about these use cases. You can also think about use cases where, with our process health solution, you understand, based on your objectives, let's say you want to increase throughput on your production lines or your quality in your production lines, how does that inform your maintenance strategy? If you're running your machines faster, or at a different rate, or using a different material, but you still want to produce your quality product at a lower cost, do you need to maintain your machines more often? Which machines are more likely to fail? Which spare parts you will eventually need in your inventory for immediate replacement in case those machines fail? So now we're moving much closer to the ability to do that, to predict that level of operational insight and essentially autonomy, right? If you are a leader within manufacturing, you're asking strategic questions like, is it better for me to produce this type of product here? How fast can I produce it? What does it mean for me to produce it, standardize it? How quickly can I change it across my plants? And again, I think with machine health, process health capabilities, we're moving much closer to be able to answer those questions more accurately, and definitely much faster than manufacturers are able to today.
Well, Artem, I wish our 23-minute window was longer, because having a conversation with you is both fascinating and easy. We really enjoy it, but we're at that end point where we have to let everyone know that you can hear us on Apple Podcasts and Google and Spotify, and we're starting to branch out into AM/FM radio. So we appreciate you being with us, and thank you.
It's been really a privilege. So thank you so much.
Thank you very much. And why don't you give us your website address for our listeners?
Oh, absolutely. If you want to check out Augury, it's www.augury.com, AUGURY.com.
Easy enough. Even us humans can understand that.
That's right.
And while you're out there, also check us out. You can type in manufacturing, actually mfgtalkradio.com. You'll come right to that section of the website where you can see this podcast episode. And thank you for being with us on this episode of Manufacturing Talk Radio.